Hello everyone. Today what we're going to do to begin is discuss our homework problem from the last session. Now this problem was difficult because it wasn't anything you'd seen before. One thing I want to stress again and again is it's not necessarily at this level the correct answers that are important. It's understanding the theory that guides these questions. It's understanding how to interpret these questions and how to formulate your equations that count. That's our priority. Okay? I don't really need to see the correct answer because these are problems that you don't really have to solve. What I want to see is how you are working through the problem, how you are attempting to find the correct solutions based on the theory we have discussed. This was a perfect example. This is a fixed charge and facility location example. It is a combination of several different types. It's quite difficult. After we pass this, we're going to move into a second level. We're going to go to transportation problems, as you saw in the last session. And they are significantly easier than this. So, what we're going to do is we're not going to solve this problem because I do not need the solution from you. Instead, I want to see, or I'm going to show you how to formulate a problem like this. We're going to look at both the objective function and the constraints. When we see these, then we're going to stop because that's what I want you to focus on. We will eventually solve problems of this nature. In the next session, I'll attempt to solve one using QM, and you're going to see that there are limitations to QM. So in next week's session, I'm going to solve a problem like this using Microsoft Excel. At this level, as we get more and more complex, we start to see the limitations of QM. Until now, it has been the easier method. But as we get more and more difficult questions, it's going to become increasingly less useful because it's a very simple program. And it's designed primarily to facilitate basic managerial science problems. When you get to higher level problems, as you get closer and closer to real life, in this question here, as you combine multiple different types of linear programming, you start to see its weaknesses. So the key here is that as we move higher to increasingly complex and increasingly real-life problems, you start to require a more powerful tool to solve these problems. That more powerful tool is Excel. And we're going to start formulating problems from next week with fixed charge and facility location, with transshipment, and with assignment problems that will show you the capabilities of Excel compared to QM. Even today, in the next session, when you look at my solution, you'll see that it gets very, very complex trying to input the data for QM to solve it completely. So, without further ado, let's have a look at a fixed charge and facility location homework question. This is the homework question that was assigned to you. I expected you not to do it and not to complete it successfully because it is quite difficult. That's why we're going to devote this entire session not to solving the problem, but to formulating the problem. So let's have a look at the question. During the war in Afghanistan, the Terrico Motor Company produced a lightweight, all-terrain vehicle codenamed J-99 Terra for the military. The company is now planning to sell the Terra to the public. It has 5 plants that manufacture the vehicle and 4 regional distribution centers. The company is unsure of public demand for the Terra, so it is considering reducing its fixed operating costs by closing one or more of the plants. Even though it would incur an increase in transportation costs, the relevant costs are provided in the following table. So we see here the relevant costs, annual production capability, annual fixed costs. Which plants should remain open and which should be closed? Then we have to determine the number of vehicles that should be shipped from each plant to each warehouse to minimize total cost. So let's look at the question a little more carefully, and let's try to determine relative information. With questions like this, we can almost assume this is relevant information. It seems like they laid it out in a chart because it is all critically important. The question is, how do we take this information and convert it to a format that we need to solve these problems? So, during the war in Afghanistan, the Terrico Motor Company produced a lightweight, all-terrain vehicle codenamed J-99 Terra for the military. The company is now planning to sell the Terra to the public. It has 5 plants that manufacture the vehicle. Here's a key point. And 4 regional distribution centers. The company is unsure of public demand for the Terra, so it is considering reducing its fixed operating costs by closing one or more of the plants, even though it would incur an increase in transportation costs. The relevant costs are provided in the following table. Let's go down. Which plants should remain open? And then determine the number of vehicles that would be shipped from each plant to minimize the total cost. We have a lot of information here. Very little of it is clear right now. So the first thing we have to determine, step 1 in this situation, second, is we have to determine the decision variables. And what that means is, most of you should know, but if you're a little unclear, we have to determine what we are deciding amongst. Are we deciding which factories? Are we deciding which routes? Are we deciding how much to produce? Are we deciding how much to ship? Are we deciding how much money to spend? There are a lot of possibilities. So what we have to do is we have to look at the question very clearly. So determine the decision variables. 1, we want to determine which plants should remain open. So which plants but we also have a second aspect. To determine the total number of vehicles that should be shipped. So we have two different ideas here. We have to determine, number one, what plants are going to remain open. Plant 1, 2, 3, 4, or 5. Which of these are going to remain open? Which are going to close? Then we have to determine the total number of vehicles that should be shipped from each plant. This is not an easy thing to do because it's multiple ideas that we have to combine into one. So let's move to step 2. In this situation, step 2 is outlining the objective function. To outline the objective function, we have to understand what we're asking in the first section. So what are we trying to do? We're trying to minimize total cost. Minimize Z, where Z is equal to total cost. Now, determining total cost is also relatively complex. We can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different shipping routes. So already we see we're going to have 20 different decision variables. We also see that we have to include our fixed costs because we're looking at total costs, our variable costs, and our total costs. That's going to mean for minimizing Z, we're going to have 25 different decision variables. That is a lot of decision variables. That's not an easy thing to determine. So let's have a look at how to do it. Please be patient. As problems become more and more complex, it takes longer and longer to outline our decision variables. So we are minimizing, number one, 56x1a. This is going to take some time. Plus, and the reason I've named it 56x, which is 56 times how many times this route is run, the route name is 1A. So we'll put that down here. So this will take a while. As I said, there are 20 different ones. 21 x1e plus 32 x, oh, 32 x1c. And that's what we can see up here. 32, 1c. So we continue. 65 x1d. Now each of these four, 56x1b, 56x1a, 21x1b, 65x1d, what these represent are all of the shipping routes from plant A. Then we move on to all of the shipping routes from plant B. Plus 46x2b plus 7x3c plus 35x 4. My mistake. I got a little confused. 2c, 35x2d plus. So again, these four represent all of our possible shipping routes from plant B. We'll minimize our titles of each route, and we'll continue on to plant number 3. So we have 12x3a plus 71x3b plus 41x3c plus 52x3d plus. Again, as before, these represent the shipping routes from our third plant. So we have plants 1, 2, 3 covered. Oh, put this over here. Oh. And we'll continue with plant number 4. So we have 30 x 4a plus 24 x 4b plus 61 x 4c plus 28 x 4d plus. As before, and the reason I keep pausing is because if you're understanding what these numbers represent, understanding the overall concepts is a lot easier. If you're just typing like a robot, filling in the numbers accordingly without understanding what they represent, it is much harder to pull all of the theory together later when we're trying to put together everything that this represents. So we have these different ideas. What we're going to do now is do the final route. 45x5a plus 50x5b plus 26x5c plus 31x5d. Last one, this is every route that runs from plant 5. If we check any of these numbers, if we check what they correspond to, we can see the route. So let's look here, 4C. We come up here, 4C, and the number is 61. 5B, go to 5B, and the number is 50. 2A, 2A, number 18, number 18. So these represent our 20 different shipping routes. And the way we've outlined the question so far is it represents the idea that all 20 routes must be accounted for and minimized in the final solution. We need to ship from the remaining factories, because we are closing one or more, and from those ships, or the ships shipping the parts from each factory, we have to minimize the cost of it arriving at distribution centers A, distribution center B, distribution center C, and distribution center D. That's what we've shown so far. However, if we look up here, we want to minimize total cost. This represents variable cost. So we'll come down here and we'll say star star they're variable because they change depending on what routes are chosen. So now we're getting a little closer, but we have to also enter our total costs. So how do we represent that? In this situation, we have 2,100,000 Y1 plus 850,000 Y2 plus 1,800,000 Y3 plus 1,100,000 Y4 plus 900,000 Y5. What this represents is each of the 5 possible manufacturing plants. If they stay open, their fixed costs must remain as part of the overall total cost. If they do not remain open, then their fixed cost becomes 0. So each of these represents the choice of that factory remaining open. We're now in a situation where we've represented all our total costs. So let's highlight this information here. We'll make it a different color. Let's say purple. And we'll add another star. Here we see the purple writing represents the fixed cost for each plant. Me highlighting the key information is not important. It's only for comprehension and understanding. But it is ultimately important because it is part of what we're doing. So once we've outlined our objective function, which we've done here, the next step is determining our constraints. Now, before we do that, let's have a quick look at something. We see here there are 20 different shipping decision variables plus 5 different fixed cost variables. If we do this in QM, if we're not using arrays like we saw in our transportation problem, this will take a very long time to enter all the relevant data, because in this situation, you have to enter all of the information for each decision variable. Your spreadsheet will be 25 columns wide. And the wider you get, the more difficult it is to look at the relevant information at any given time. Also, the more information, the wider your spreadsheet gets, the harder it is to see columns A and columns 25 at the same time. Aside from that difficulty, you're going to be in a situation where it becomes time-consuming. This is still a very simple problem. Only 5 plants, only 5 distribution centers. What if it's 10 plants and 12 distribution centers? Your QM spreadsheet is going to be 120. 10 plants times 12 distribution centers, 120 columns wide. And it will be harder and harder to visually represent the information in front of you. So that's one of the main reasons, as we get more complex, that we go to Microsoft Excel. There's others, and you'll see some of them later, but one of the key reasons is being able to represent data or information relatively concisely. So let's move on to step 3, determining our constraints. So we look up here, and what are the first of our constraints? I paused the program for 1 second because I just realized the mistake I made. I didn't enter some of the relevant information. So each of these hubs, we'll space this out a little more. Please be patient. Oh. We'll put each of these in thousands. So this is our first area of complaints or constraints down here, and I should have entered this earlier. When I was copying it, I made a mistake. That's my fault. It hasn't been important until right now. So this is the number in thousands of how much each plant requires. So our first constraint is underlining how much plant number 1 requires. And the way we do that is adding together the shipments from plant 1 to A, 2 to A, 3 to A, 4 to A, and 5 to A. So down here we make it 1x 1a plus x2a plus x3a plus x4a plus x5a is equal to 6,000. And what we've seen here, what this represents is all of the shipments total from each of the 5 plants must equal 6,000. If it doesn't equal 6,000, demand has not been satisfied. And if demand hasn't been satisfied, it is not a possible solution. So here it is, demand So now we go down C2 and we're going to repeat it. X2A plus 1B plus X2B plus X3B plus X4B plus X5B is equal to 14,000. And that represents demand at distribution center B. So we'll minimize again because that's only our shipping routes of the name of the shipping route. With each of these, you're going to see that as these become increasingly complex, it's understanding the concepts that will allow us to solve problems like this in reasonable amounts of time. Because if we always have to write all of our variables like this, it is going to get time consuming. It is also going to get confusing. But for now, let's continue. C3 X3 X1C plus X2C plus X3C plus X4C plus X5C is equal to 8,000 units. And we're seeing that right here. All shipments from 1, 2, 3, 4, 5 to C must equal 8,000 units because that is demand center C. Again, we minimize because these represent only the shipping routes. When we are filling it into our spreadsheet, if we were using QM, this does facilitate things by making sure we make fewer mistakes. The last one from this section, C4, X 1D X1D plus X2D plus X3D plus X4D plus X5D is equal to 10,000. And that is demand at distribution center E. Very simply. So one final time, we'll go through this and we'll see these are all of the units being shipped from each of the 5 plants to distribution center D. That's our first 5 constraints. However, we're not done. C5, we see up here that we also have the annual production capacity. What this represents is another limitation, because we cannot produce or we cannot ship goods if they don't exist. For each of the 5 production plants, we have only the total that are produced in that, we can only ship to each of the 4 distribution centers the total goods produced in each plant. So we're going to represent that by saying X1A plus X1B plus X1C plus X1D must be less than or equal to 12,000. This is the number possible to ship from plant A. Come up here, we minimize, and I'll explain in 1 second, but we have so X1A, 1B, 1C, 1D is right here. X1A, X1B, X1C, X1D is 12,000. So the total shipped from plant 1 to distribution center A, distribution center B, distribution center C, and distribution center D must be less than or equal to 12,000. We're going to repeat that for C5, C6, C7, C8, and C9. Let's do that now. Please be patient with me. So we have X2A, which is the shipments from plant 2 to distribution center A, plus X2B, the shipments from distribution center 2, plant 2 to distribution center 2, B, X2C, the shipments from plant 2 to distribution center C, and X2D, the shipments from plant 2 to distribution center D, must be less than or equal to 18,000. And that's because those are the amount of goods that exist there. So X3A plus X3B plus X3C plus X3D plus X3E is less than or equal to 14,000. And that's the number possible to ship from plant C. Again, we minimize all just for simplicity's sake. It's not necessary to minimize anything, but it does help us understand that these numbers and letters don't affect anything. Instead, they're just placeholders indicating shipping routes. We continue again. X4A plus X4B plus X4C plus X4D is less than or equal to 10,000. And that represents the number possible ship from plant. So minimize again. This will look more intelligible, easier to read when we are finished because I'm minimizing everything. And finally, for this section, our final constraint, x5a plus x5b plus x5c plus x5d less than or equal to 16,000 units. I made one mistake here. I misnamed my plant. So this is 1, and this doesn't really matter, but to make it a little more clear. Okay, so we minimize a final time in this section. And what these represent is all of the goods we possibly can ship. So we have the goods that are required each center. So we can't just close any factory. We can't just close any shipping route because it's not randomly determined. If we have the prices and we know the fixed costs, then once we have that, we can look at what each center requires, what each plant manufactures, and we can solve this equation. But not yet. We have one more section, C10. And this represents our plant decisions. Which plants will we keep? Which will we let go? That's what we have to determine here. We haven't even done that yet. So let's check. And we see x1a plus x1b plus x1c plus x1d must be less than or equal to 2,100,000. And what this means, if we go up here, we see that if these are chosen, x1a, x1b, x1c, x1d, we're going to have fixed costs of 2,100,000. And this is going to be represented by if they are chosen or not. So we're going to realign that a little bit, and we're going to okay, so only for this one we'll do a separate idea. So we'll change it a little bit to x1a plus x1b plus x1c plus x1d is minus 2,100,000 is less than or equal to 0. And this is an algebraic an equation transformation. We'll just leave it like that, following very basic rules. And the reason we're doing it this way is just it gets a little bit easier later when we're entering information into the computer. So we'll go down, we'll do C11, C12, C13, and C14. And these are going to represent our 5 possible plants, which remain open and which remain closed. So X, x2a plus x2b plus x2c plus x2d minus 850,000 is less than or equal to 0. One more time. x3a plus x3b plus x3c plus x3d plus x3e minus 1,800,000 is less than or equal to 0. If plant 3 is chosen, the fixed cost. 2 more times to go. And I guess we could minimize all of this. We'll just continue for now. So x4a plus x4b plus x4c plus x4d is minus, oh, I made a mistake up here. I went one too far. Minus 1,100,000 is less than or equal to 0. And that's if plant 4 is chosen, the fixed cost. Last one, x5a plus x5b plus x5c plus x5d is less than minus 900,000 is less than or equal to 0. If plant 5 is chosen, the fixed cost. Okay, so each of these numbers represent the cost, or each of these constraints represent the fixed costs that would exist if that plant remains open. So what we have to determine is which of the final 5 variables will be 0, 1, 0 if the plant is not chosen, 1 if it is, and which of the 20 shipping routes will be chosen. And that will give us our shipping costs. So we are seeing how complex this problem is, but the setting up of the problem remains relatively similar to what we've done. It's just a growth on what we've done so far. So as I said, we're not going to solve this problem today. In the next session, I will attempt to solve a problem, but you'll see it gets quite tricky at the end because QM isn't really designed for problems of this complexity. Instead, we almost need another program like Excel that will allow us to solve increasingly complex problems like this. We're seeing not 1 or 2 variables, but 25 decision variables, and not 1 or 2 constraints, but 15 different constraints. 14 different constraints. So we're seeing right away, this is a complex problem. Hopefully everybody's followed along. Hopefully session 2 gives you a little more information, and hopefully everyone's comfortable. If you have questions, please contact me. There is no homework this week because I want you to focus on this type of question. Anyways, have a wonderful day, and I'll see you shortly in session 2.